question, right? Here we are talking about. Then cos alpha is given. That is, cos alpha is given 3 by 5, 2017. And so AD on the smooth, okay. So a light inextensible string of the length L passes over the small smooth pulley at P, right? Okay, has a particle P of mass M attached to one end and another particle Q of the same mass M attached to the end. The system is released from the rest with the strings towed that the particle P held at the midpoint of the AB, okay, and the particle Q on BC is shown in the figure. So this is particle P that is kept on. Okay, so particle P held at a midpoint of the AB. Okay, so show that the acceleration of the block related to the floor is something like that. Find the acceleration of the okay, so they are talking about that C. Okay, come back to this. This is the midpoint. This is in the midpoint of AB. So I just mark like that. That's better to have like this. This is midpoint of AB. So this is P. So right. Okay, so first of all, as usual, they asked to find the acceleration of the wedge and then the acceleration of the particle. So they after that they talk about something time and everything. Okay. Okay, first of all, what we have to do. First of all, you have to mark all the forces. So I mark all the forces. I think it is better to have another. Let's see, it's okay. So first of all, 2 mg, say 2 mg, right? And reaction S. Here mg, here mg, here reaction R, and here reaction R. So here I put reaction N. Here I can put plus N. Okay. If I want, I can put plus N. Or if you want to put separately, you can put N like this. So that's up to you. Right? Okay. Right. So the tension T, so that is T here and T here, and there will be T here and here. I didn't mark that, but actually this is moving particles nearby. I have to mark. Okay. So hopefully. So first of all, you have to mark all the forces. Let me know if I mark all the forces, right? So N to Mg, 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 reaction, then tension. That's it. Okay. Now I have to mark the acceleration. I know that this the system, this wedge will move in this direction. So I mark here capital F. Okay, acceleration of wedge related to the Earth, capital F. So according to the wedge, the particle will move in this direction. Here I can mark somewhere here. So that is simplest. I mark like that. This one. This one also having simplest. Same simplet. Why? Because these two particles are connected by a string. If these two particles are connected by an inextensible string and like this, so then according to the wedge, the acceleration of this particle and acceleration of that particle, both are same. Okay. Actually, the magnitude of the acceleration of this particle and magnitude of the acceleration of this particle, both are same. Okay, so direction different. So this particle's direction here, according to the wedge, this particle's direction in this horizontally according to the wedge. But magnitude must be same. If it's simpler, this is also simpler. Okay, so all of you know that we have to apply F equals ma. So F equals ma must be applied in the frame of inertia. So then we have to, frame of inertia means the normal frame. So example of the frame of inertia is a Earth. Earth is the one of the frame of inertia, right? Because what do you mean by frame of inertia? The frame which is stable or which is moving in the constant velocity, so which has no acceleration. So in that those kind of frames we call frame of inertia. Right. So we have to apply F equals ma in the frame of Earth. So we have to find each and every particle's acceleration in the frame of Earth. So here, this capital F is frame of Earth. Yes, according to related to Earth. But this simple M is not related to Earth. This simple M is not related to Earth. So what we have to do, so this wedge's acceleration also will be there in the on the particle. So this acceleration we have to put here, right here and here, the same direction. Okay, is it clear? Because the particle depends on the wedge, which depends on the Earth, like that. So whatever you mark on the wedge, that is related to Earth. Whatever you mark on the acceleration you mark on the particle, that is related to wedge. But actually what you need to find the acceleration of the particle related to Earth. Then wedge's acceleration also will be there for particle, right? So we have discussed this in several classes, right? So very important concept. Right, now what we have to do, we have to apply F equals ma. So how to apply F equals ma? What is a suitable direction, suitable particles or suitable thing to you choose? So first of all, you have to apply for the system, right? So horizontally. So F equals ma. I'm going to apply to the system. So if you want, you can write like a system. I write 2m, m, and m all together. So that I consider as a system. The system is moving in this direction. So if the system moves in this direction, what is the resultant force acting on the system in this direction? There are no RR cancel, S is perpendicular, N is perpendicular, N is cancel, and MG all are cancelled. So there are no forces, right? So zero force acting on this direction. Now forces, okay. Now what we have to do, M into A. M into A means if you consider this as a big block, capital M, that you can put capital M into F. But this is not like that. So this is the capital, this one is moving in this direction with the different acceleration related to Earth. This particle moving in this direction with the different acceleration related to Earth. And this particle also moving in this direction with a different acceleration related to Earth. So what we have to consider, each and every particle, each and every mass. So first of all, we consider as 2m, which is the wedge, mass of the wedge, and 2m into what acceleration? Capital M plus. Then simple m, this simple m into, I can go for capital F minus simple m plus. Then this simple m into, I can write, we know that this is alpha, means this is also alpha. So capital F minus simple F cos alpha. Is it clear? Is it clear? M into capital F minus M into capital F minus simple F cos alpha. Right? Okay. So if you write this equation, I think you will get 15 marks for this. I think so, not less than that. Right? Just if you by writing this equation. Okay, so now the system we consider the system. After that, what we have to do, right? After that, what we have to do, we have to consider each and every particle. That's it. So first we will consider this particle, simple m, in the direction motion, in the freedom of motion, right? Freedom of motion, in the direction of the freedom of the motion, we have to apply F equals m. We have discussed about the freedom of the motion in the last classes, but freedom of the motion means that if the particle intends to move, that is we call the freedom of motion, right? So in that direction only we mark the acceleration normally related to wedge or related to wedge for the particle. So in other way we can say we can apply F equals ma in the direction of direction of the acceleration, right? So in this case, we are going to apply, we don't apply upward, so we have to apply horizontally. So you can apply this direction because the particle moves in this direction according to the wedge. This direction you can apply if you want, or you can apply this direction. So it is better to apply in this direction because according to the wedge, particle intends to move in this direction. So T is the only force acting on the simple F. So T equals simple M into, so don't forget that simple F minus capital F. So we call this is equation 1, this is equation 2. So again, 15 marks we will get. So here, again, this one, for this is for Q, this is for P. So the P moving in this direction, okay, so mg cos 90 minus, so mg sine alpha, the force minus T, or force m into, in this direction you have to put the acceleration, simple F minus capital F cos alpha. Simple F minus capital F cos alpha. Third equation. So that's so enough. We know that there are three unknowns, capital F, simple F, and T. So it's there. So three equations are there. So we can solve it. So you need to consider how to apply and so for which particles which or we have to choose. So you have to consider that. So the first one we have to consider the system and which the system intends to move. That means the freedom of motion of the system. Second one, freedom of motion of the particles, right? So in that direction, if you apply, so that will be okay. Is it clear? Is it clear? Right. So now we are going to solve this. We know that obviously we have to eliminate the t. So we add 2 and 3. So I can write it here. Add 2 plus 3, that implies mg sine alpha. If you add, you can take the simple m as a common because both are simple. So f plus f2f, and here minus you can take 1 plus cos alpha into capital F, right, like that. So you can cancel the m later. So g sine alpha is going to be 2 simple F minus 1 plus cos alpha into capital F. Actually, we know the cos alpha 3 by 5, so we can put later. Okay, so later we can put it here also, we can put, that's up to you, right? So this is going to be equation 4. So please copy if you don't have this notes. Okay, give me a second. Okay. Right. So we will erase. Sorry. So this is the fourth equation. That is, that's fine. So how to solve this now? That is the challenging part. That is not challenging part for us because we know the technique. So what we can do is we have to arrange the first equation. So I think it is better to erase this part because I have to use the first equation. Okay, anyway, I'll erase this one. Okay. Third one also. I can write first equation. I can cancel all the M. 2 capital F, 1 F, 1 F, 4 capital F. Right. Then minus F cos alpha. So if you take the minus F out, simple. That's it. Right. So the first equation I can write further in the way of you bring this to this side, F, and this is capital F4. So you can change like this. So you can put capital F1 plus cos alpha here and 4 here. So do you understand? So the first equation, what you can do, I took this side, then 1 plus cos alpha into F and 4F, I bring the 4 down and I bring the 1 plus cos alpha down here. The same equation converted like this. Why we do? We know the techniques. We are using the DC rule to find the these kind of things. So I explained in last classes, right? So we talk with this equation now. It says 2f minus 1 plus cos alpha into capital F can be substituted by g sin alpha. We talk with the equation 4. It says 2 into simple f minus 1 plus cos alpha into capital F will be g sin alpha. That means, in other words, if you multiply simple f by 2 and capital F by 1 plus cos alpha, and if you subtract, you can put g sin alpha. So I put g sin alpha here. So what I have to do, I have to make 2s here. I have to make 1 plus cos alpha here. I subtract it. So I top and bottom, I multiply by 2. Then this will be 8. So 8 minus top and bottom, I multiply by 1 plus cos alpha. This will be 1 plus cos alpha whole thing square. So that's it. So I erase here. So tell me, what is capital F? Capital F is, if you cross multiply 1 plus cos alpha into g sin alpha. So sin alpha into g over this part. If you want, you can expand it. Whole things. So that is. But actually, they ask numbers because cos alpha, sin cos alpha is given. So now we can substitute. Why I do like this? Because if they give in an alpha without giving these numbers, you will be doing like this, no? So you have to do like this also, no? So to have that knowledge, only I kept the sin alpha and cos alpha without substituting. Now I can substitute. So what do you mean by simple f? If you want simple f, you can cross multiply by 4, and that is simple f. Okay. So first of all, okay, I would put simple f also. 4g sin alpha, 4g sin alpha over 8 minus 1 plus cos alpha whole thing square. That's it. So this is our technique to find the accelerations in the wedges. So otherwise you will struggle by multiplying, subtracting, substituting, and all those things. Okay, so I erase this part now. I can erase this because I found the answer. So erase this one. So if I substitute for cos alpha, if cos alpha is 3 by 5, sin alpha will be, this is 3, 5, 4. 4 by 5. Okay, so I substitute cos alpha. Capital F is 1 plus 3 by 5 sin alpha 4 by 5g over 8 minus 1 plus 3 by 5 whole thing square. What is the answer? 8 by 5. This is 8. This is 8 by 5. So 8 by 5 into 4 by 5g over. This is 8 by 5 whole thing squared. So 8 minus 8 by 5 whole thing squared means 64 by 25. So if you uh, simplify, you can cancel the 8 and 4 by 25, and you can cancel, okay, you can keep that 8. So 1 minus 8 over 25. So 4 by, this is 25 minus 8, 17, G. So G, is that answer? Is that answer? 4G by 17 is the answer. Yes, that is the answer. Please consider this. Give me 1 minute. And find the simplest also. Okay, so simplification is very important in wedges. So let's see. Okay, so what is did they ask about the acceleration? Find the acceleration P related to the block. Oh, that is also okay. So we don't care about that one. So we can use this one, or you don't need to substitute there. So we can use simple F is 4a capital F by 1 plus cos alpha. See, 4 capital F by 1 plus cos alpha. You can use that relationship, or you can substitute there. That's up to you. Okay. So I think it's better to use this one. Simple F is 4 capital F over 1 plus cos alpha. So I can do this one, right? 4 capital F over 1 plus cos alpha. 4 capital F over 1 plus cos alpha. Right. Simple F will be 4 capital F. Capital F is 4 by 17G into 1 plus cos alpha. 1 plus 3 by 5. So it is going to be 8 down. So I just 4 into 4G over 17 over. This is 8 by 5. So you can cancel 8 and 4. That's 2 will be here. So it goes up. That is 20 divided by. This is 20 divided by 34. Actually, you can 10 by 17 by, isn't it? Okay. Right. So 10 by 17 G. Is that anyone got this answer? 10 by 10G by 17? Anyone got this answer? 10G by 17 for simplest? Right? Anyone there? Okay, so I just do, or you can substitute here also, because I found both at one. Okay. So if you want to substitute there, then sin alpha be 4 by 5, then 16 by 5. So again, same thing. So same thing. So, but I used the previous expression to find this. Okay. So we found that. So finally, what they say. Now only that they say, show that acceleration, okay, but also show that the time taken by the particle P to reach the A. Oh, so that's why I didn't erase this, because we have to identify what is happening. So what they say, so you have to find the time taken by the particle P to reach the A. So particle P here to here. So the total length is 2A. then this length must be A, because they say this is the midpoint, right? So this is starting from the rest. The P is starting from the rest and it's coming down. So what you can do, so your time taken for the particle to reach the A means you have to apply S equal ut plus half at squared according to the wedge, right? According to the wedge to the particle P. So shall we do that? Yes, so we can erase this right now. We can erase everything, right? Okay, I erase this. I keep that 4G by 17 for capital F, right? That capital F 4G by 17, simple F 10G by 17. Let's see whether it's possible. Okay, so I'm going to apply S equals ut plus half at squared to the particle in this direction, right? For who? The particle P, right? So according to the wedge, okay, related to the wedge. So respect to wedge, okay, to the particle P, respect to which I apply S equal ut plus. So A is the displacement, and initial is zero. Initial velocity is zero because starting from the rest. So half A, that is simple F T squared. So that's it. So A equals simple F is 10 by 17. So if you substitute that 10 by 17 GT squared, I don't know whether it's correct or not. Let's see, we'll check the answer. Okay, so I erase this part. So this will be 5 and A equals 5G by 17 T squared. So T squared will be 17A by 5G. So is the answer there? Yes, of course, 17A by 5T. And T will be square root of 17A by 5G. So that is the final answer. So that is the end of 2017 paper. Okay, so what we have done, so it's just it's a nice question. Actually, this kind of question is the similar question repeated in 2018 also. So we have to do that one. But here the important thing is applying F equals MA and choosing the suitable occasions, so suitable particles and suitable direction, right? So after that, so you will be getting this, and simplification is that matters, right? So we know that we can use the DC rules what we have learned in basic A level, right? So then or you can subtract and you can do any other method you can come up with, right? So here, this is the half ft squared, this is it. I'm applying this respect to which to the particle. So only simple F will act, okay, respect to which. If I apply respect to Earth, that will be a different story. So this is the answer. So finally, it's the end of 2017 past paper. Is it clear, all of you? Is it clear? Okay.